This video is an extension of 5.6. However, this time we are going to do a couple of different things. First, we're going to write expressions from exponent form to radical form and then radical form to exponent form. We can do this because they are inverses of one another. And then we're going to take a look at your properties of exponents. Only instead of using whole numbers, we're going to use fractions. And you already saw this in your 5.6 introduction. So hopefully today is a little bit easier and goes smoother than our 5.6 day one. All right, this is something that I just screenshotted from the textbook. It talks about how you could write it from one form to the other, starting with, I guess I'll look here. If I have a rational exponent, so that just means a fraction in my exponent, and it's 1 over something, I can just write it as the root of. Or if I have a fraction m over n, so two different numbers, I can rewrite it with the nth as the index and then m as the power. I have an easier way, I think, to remember this. All I do when converting them is just remember this one rule. Power over root. In the fraction, the numerator is the power, the denominator is the root. Let's see this in practice. Take a look at example 3. We have negative 125 to the 2/3 power. So I want to write it from the fractional exponent to the radical form. Well, keep in mind, power over root. So 2 is going to be the power, 3 is going to be the root. So I am taking the cube root of negative 125, and that is going to be squared. Let's do it again. Power over root. I am taking the 4th root of 64, and I'm going to raise that to the first power. So you could leave it like this, or if you really wanted to, you could show raising it to the first power. Either way, they're equivalent. Part C, once again, power over root. I'm taking the square root of 4, and I'm raising it to the 5th power. All I've done for example 3 so far is write them from the rational exponent form to the radical form, but notice how it does say in the directions that we need to simplify. So I could actually evaluate these. The cube root of negative 125. It's okay to take the cube root of a negative number. We're just going to get a negative number. The only time it's not okay is if it has an even index. So the cube root of 125 is actually negative 5, and that's being squared. Negative 5 squared would give me a positive 25. So positive 25 is the solution there. Okay, now I have the 4th root of 64. 4th roots, I understand, are a little bit more complicated for some people. So if you don't have them memorized off the top of your head, just try different things. What to the 4th power would give me 64? So let's try 2. 2 to the 4th power, 16. Nope, that doesn't work. 3 to the 4th power, 81. Nope, that doesn't work. 4 to the 4th power, 256. So none of those work. Now we got to think about the factors of 16. We said that 2 to the 4th power was 16. So 64, is that divisible by 16? Yes. 16 times 4 would give me 64. So I can rewrite this as the 4th root of 16 times 4. So 16 is the perfect 4th power of 2. So I'm going to pull out that 4th root of 16 to give me 2 on the outside. And then that 4 needs to stay behind. giving me 2 fourth root of 4. Okay, next I have the square root of 4 raised to the 5th power. Square root of 4 is pretty easy, that's just 2, so 2 to the 5th power. If you're not good at doing it in your head, so 2 times itself 5 times, go ahead and plug that into your calculator. You'll end up getting 32. So example 3, we started with fractional exponents and turned it into radicals and simplified. Now what we're going to do is I give you the radical and I want you to rewrite it as rational exponents, so fractional exponents. Just remember, power over root. This is the power. Here's my root. So it's going to be 7 to the 3, which is the power, over the 4, which is the root. And we're not asked to simplify this one, so that's the only answer. Now let's do it again. I have 11 to the 6 is the power, 3 is the root. So power over root. Notice how you could simplify this. 6 divided by 3 is 2, so that's going to be equivalent to 11 squared. Which is pretty easy enough. 11 squared is going to be 121. Okay, and then C, we have power over root. So I have 5 to the 2 fourths power. 2 fourths does simplify, so I could say 5 to the 1/2 power. And we already talked about before how the 1/2 power is equivalent to the square root. So you could write it as a square root of 5, but then you wouldn't be following the directions, which says to write it with rational exponents, so basically a fraction exponent. If we put square root of 5, we're going back to radical form, and we don't want to do that. So I would leave it as 5 to the 1/2 power. Okay, properties of exponents. We already did this in your 5.6 introduction, so I'm going to go through this kind of quickly, and hopefully you'll be able to keep up and understand everything. First, we're going to take a look at the product property, which says when we multiply by the same base, we add the exponents. So 12 is my same base. I can add the exponents. That gives me 12 to the 1/2 plus 3/2. It already has a common denominator, so I can add to get 4 over 2, which simplifies to 2. Oops, probably would help if I scoot it over. And 12 squared is 144. Next, you can see the properties on yours. I'm just going to leave it here. We have a power to a power. When we have a power to a power, we multiply. So this is really 8 to the 2/3 times 3. Now remember, this is technically 3 over 1, and we go across the top, across the bottom. So 6 over 3, or 8 squared. Notice how you could have also just canceled out the 3's to get 2 over 1, or 2. And 8 squared is 64. Now, we have 2 different bases raised to the same power, which means we're going to have to distribute that power to both of the terms. That's 16 to the 1/2 power times 25 to the 1/2 power. And I know that the 1/2 power is equivalent to the square root, which makes this pretty simple because the square root of 16 is 4, and the square root of 25 is 5, and 4 times 5 will be 20. Number 4, we have a negative exponent, and whenever you have a negative exponent, that means we need to move it from the numerator to the denominator or the denominator to the numerator. This is in the numerator position, so I'm going to have to move it down to the denominator. And that act of moving it makes the exponent positive. Now, if 1/2 is a square root, so 1/3 would be the cube root, 1/4 would be the fourth root. So you basically just ask yourself what to the fourth power would give me 256. So, oh, I think I already did this. I'm going to do it again. You could either ask yourself that, or you could do the fourth root of 256. Just plug it in right away, and you get 4. I'm pretty sure I already showed that to you guys, though. All right, so that gives me 1/4 as my answer. Next, we have the quotient property, which says if we have the same base, we subtract the exponents. So that's 125 to the 2/3 minus 1/3. Well, 2/3 minus 1/3, they already have a common denominator, so I can subtract 2 minus 1, which is 1, 2/5 to the 1/3. So 1/3 means that it's going to be the cube root of 125, which is just 5. Next, we have a quotient, but they're raised to the same power. They have different bases, so I need to distribute 16 to the 1/3 and 81 to the 1/3. Cube root of 16, cube root of 81. You know, looking at this, I think I had a typo because that doesn't work out very nicely. Why don't we make this a 1/4? So we're taking the fourth root. There we go, that fixes it. Because I wanted it to have the fourth root of 16, which is 2, and the fourth root of 81, which is 3. And remember, how I got that was asking myself what to the fourth power would give me 16, and what to the fourth power would give me 81. If that's difficult for you, plug it in. What is the fourth root of 16? It's 2. What is the fourth root of 81? It's 3. So hopefully we're becoming more comfortable with our calculators. Why don't you pause the video and try example 5, since you've seen this twice now, and we'll see how you do here in a minute. For 5a, I added the exponents, which gave me 5/5, or 1, so 25 to the first power is 25. B, I subtracted the exponents, which gave me a negative 1/3 power. A negative exponent means we have to move it, so from the numerator to the denominator, and I know that 1/3 is equivalent to the cube root. So the cube root of 8 is 2, meaning your final answer should have been 1/2. C was very similar to B, except that we ended up with 1 over negative 8 to the 1/3 power, or the cube root of negative 8. It's okay to have the cube root of a negative number. The only time it's not okay is if it's an even root. So I would just put negative 2 in place of the cube root of negative 8, giving my final answer of negative 1/2. For D, we had the cube root. I rewrote it as the cube root of 8x cubed. 8 is a perfect cube of 2, and then I could pull out that x because that was also a perfect cube. E, I could see giving some difficulty. I just showed all my steps here. Because this was a quotient with multiple variables, I just went ahead and subtracted all of the powers. So 2/5 minus 7/5, 1 minus 1/2, 1/3 minus negative 2/3. So I wrote that step here, and then I went ahead and subtracted, which gave me a to the negative 5/5, b to the 1/2, c to the 1/3 plus 2/3, because there was a sign change. Cleaning that up, I got a to the negative 1, b to the 1/2, c to the first. But this is still not acceptable because of that negative exponent, so I had to move it down. And you could have rewrote it as the square root of b, but you didn't have to. Both of these are acceptable answers.